Find dy if y equals x to the fourth minus 6x cubed plus 2, and x is equal to 3, and delta x is equal to negative 0.1. First step, of course, is to write down the formula for the differential dy. dy is equal to f prime of x dx. F is a simple polynomial function, so its derivative will be easy. 4x cubed minus 18x squared, of course the derivative of 2 is 0, times the differential dx. Now here we're asked to evaluate that differential when x is 3 and delta x is negative 0.1. And remember, delta x and dx are the same. So it's simply a matter of plugging 3 in for x and negative 0.1 in for dx. Doing that, we get 4 times 3 cubed minus 18 times 3 squared multiplied by dx, which is negative 0.01. Now it pretty much becomes an arithmetic problem. 3 times 3 times 3 is 27. 27 times 4 is 108. 3 squared is 9, and 9 times 18 is 162. 108 minus 162 is negative 54. So we multiply that by negative 0.1. And we end up with the differential being positive 5.4. Let's look at another one. A little bit harder derivative, but basically the same process. Again, the formula, dy is f prime of x dx. Here, f of x is a square root, and at some point you're going to have to remember that a square root is the same as a 1/2 power, so you might, at least in your head, even if you don't write it down, keep in mind that we're working with a 1/2 power. So the derivative, according to the chain rule here, if we're looking for the derivative of f, is 1/2 times 1. Write the base down, 2x plus 7, and then subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. And then, of course, that's multiplied by your differential, by the derivative of the inside, by the chain rule. And that's f prime of x, and it's multiplied in the formula by dx. Notice the 2 times the 1/2 just gives you a 1. And that a negative exponent means 1 over the positive value. So what you really have here is that dy is equal to 1 over 2x plus 7 to the 1/2 power times dx. And of course, the 1/2 power is really a square root, so you have the square root of 2x plus 7 in the denominator times dx. Now they ask us to evaluate this when x is 3 and delta x is negative 0.01. And remember, dx and delta x are the same thing. So now it's a matter of putting 3 in for x and negative 0.01 in for dx. So we get dy equals 1 over the square root of 2 times 3 plus 7 times the differential, which is negative 0.01. Continuing, 2 times 3 is 6, 6 plus 7 is 13. So that becomes 1 over the square root of 13 multiplied by the differential for x dx, which is negative 0.01. Now I would at this point maybe notice that that's like an understood 1, so you can think of this as top times top, which gives you negative 0.01, bottom times bottom, which just gives you the square root of 13. And at this point, it's just a matter of using your calculator and getting this. And there are different ways of doing it, but for me, I would probably just use the memory key. Start off calculating the square root of 13 and use the memory key to store it, and then I can do the division. So if I'm looking up here at my calculator, I want to do 13, and then the square root is the shift above this x squared key, so I hit that. Whoops, I forgot to hit shift. 13, shift, and I want to store that. There are different ways you can do this, but to store this with this calculator, there's an MN that's a shift over the MR. So if I do shift MR, I've stored that in memory. You notice a little M comes up telling you I've stored it. So now I can take the numerator and divide it by the denominator, but I'll have to recall it. So I put in 0.01. Remember, you can't put in a negative number directly, and you hit the plus minus key to change it to a negative. Then you divide by, well, I want to divide by that quantity I just stored. Well, the MR retrieves the number I calculated earlier from memory. So if I hit MR, that square root of 13 comes back out, and now I hit equal, and I've done the division. You do need to notice, though, that this is the calculator's version of scientific notation. That exponent here being negative means that the decimal place really has to be shifted back to the left. If it were positive, it'd be to the right. And the 03 means it's got to go 3 units to the left. So instead of it being negative 2.7735 and on, it's actually that number with the decimal shifted 3 places to the left. So what you end up with is negative 0.00277, and of course on and on. But the problem says to round the number to the nearest 1,000th, the final answer. So I want to take that answer I have and round it to the thousandth place. So that would take it up to 003. So the nearest thousandth, the differential dy would be negative 0.003.